Okay, hello and good evening, everyone. Thank you for joining us for Temple Engineering's session for the Department of Civil and Environmental Engineering. Glad you're all able to join us tonight. Just a quick housekeeping item. We are recording this session, so it'll be available for future viewing. Probably sometime tomorrow or the next day, we'll be posting it to our website, and we'll also send it out via email as well. And if you could also hold all of your questions until the end of the session, you'll have the opportunity to ask questions of our faculty that are joining us, as well as we have 2 current students that are available as well. So we're going to go ahead and get started. And this photo here was obviously taken pre-social distancing, but we hope to get back to campus very soon. So I'm Colleen Bailey. I'm the Director of Enrollment Management for the College of Engineering. And before we get into the specifics about civil engineering, just a quick history of Temple Engineering. So we were founded in 1969, so we just finished our 50th anniversary year, which is very exciting. We have a little over 1,700 total students, about 1,500 undergraduates, and a little under 200 graduate students. Our undergraduate student body is 25% female, which is above the national average. The national average for most schools and colleges of engineering is usually in the low 20s, maybe 21 to 22%. So we're above that, which is very exciting. 37% of our students identify as non-white, so we have a very diverse student body, and we also draw students from throughout the globe. We have 136 undergraduate students that are international students as well. For the Department of Civil and Environmental Engineering, we have a little over 400 total students in that department, 377 undergrads and 42 graduates. And you can see here that the demographics of the department basically mimic the school. It's about 25% female, about 35% underrepresented, and we have 37 international students, undergrads, that are in the department. So without further ado, I'm going to turn it over to 2 of our faculty who are here tonight. They're going to tell you all about the majors in civil and environmental engineering and the opportunities that are involved. So without further ado, I'll turn it over to Drs. Coe and Dr. McKenzie.
All right, thank you very much. And we're very pleased to have all of you here. Just to tell you a little bit about myself. So I am an environmental engineer. I did my undergraduate degree as an environmental engineer. And then as my master's and PhD officially say civil and environmental engineering, it was really entirely environmental engineering. I joined the faculty here at Temple University in 2015, so I've been here for a little bit over 5 years, not 15. And in both my teaching and my research hat, I specialize in looking at how chemical contaminants, you might call those pollutants, how they move through systems and how they change in systems. So officially, we call that fate and transport. Dr. Coe?
Thanks. So yes, my name is Joseph Coe. I am an associate professor within the Civil and Environmental Engineering Department here at Temple. I've been at Temple since 2012, so going on now 8 years. And prior to that, I was a professor at a smaller university in Charleston, South Carolina called the Citadel. Let's see, I ate breakfast, lunch, and dinner at UCLA, all my degrees there. Did a minor in geology, was originally thinking I was going to be a structural engineer, went in and hit a few snags along the way, and realized that geotechnical engineering was my calling. So I am a geotechnical engineer by training, and I run the Geotechnical Research Laboratory, which we'll talk about sort of the research things we do in that particular lab in the future. Looking forward to telling you guys a little bit more about civil engineering. Can you go to the next slide, please, Colleen? So in terms of the civil engineering and environmental engineering, our department is civil and environmental engineering. The 2 of those go closely hand in hand together. Basically, when we talk about civil engineering disciplines, we are talking about everything related to infrastructure, everything that is necessary to make the world function, to get things from point A to point B, to ensure that we have enough water and enough clean water. That is all part of the different disciplines, particularly my side of things, which is more traditional civil engineering. You've got structural engineering, you've got geotechnical engineering, transportation engineering, construction management, and all of that is essentially geared around building things that help our society function. Erica, you want to take over environmental?
Yeah, sure. So for environmental, we see down kind of on the bottom 2 lobes of this 6-sided figure that we have here, we have environmental and we have water resources. So when you think about water resources, you're often considering primarily how much water. And we have to remember that water is extremely important for sustaining life. We have to have water for drinking, but also if you have too much water in the wrong place, it can be a real problem. So you can have flooding and the hazards associated with that. So water resources looks at trying to manage and understand those aspects so that you have water where you want it and you don't have water where you don't want it. Then coupled with that, we also want to think about water quality. So we understand that water that's in a river might not be safe to drink, but there are things that we can do to it to make it safe to drink. Environmental comes into that, and as we're thinking about those water quality aspects, but it also goes into other areas. So we can think about, taking a site that has been contaminated for some reason. What can we do to improve the conditions in that area so then we can reuse it for another purpose? It also includes things like air quality, both indoors and outdoors. So environmental engineering can cover a lot of different aspects that cover both chemical aspects. So like I said, I think about pollutants. It can cover microbes, so both how we can use them beneficially to achieve some endpoint, but also maybe ones that are bad for our health. And then also physical processes. So how can we achieve some engineered outcome? All right, go ahead and go to the next slide, please, Colleen. Okay, so while you're here at Temple CEE, or at Temple, there's a couple things that I want to highlight. So, when you think about a civil and environmental engineering curriculum, there are going to be some similarities that are true regardless where you are. So right now I want to highlight a couple aspects about our programs that we think enables us to deliver a better experience. So the first one is, here you have a sense of the faculty that are in our department. And so for essentially almost every course that you would take in the civil and environmental engineering curriculum, it would be taught by a faculty member. Now, sometimes we do bring in external experts, adjuncts, who really know a lot about a particular subject matter, and they'll teach that class because they have so much experience and expertise to share on that front. We are also able to have smaller class sizes. So here you can see that 30 to 1 is what we're showing on this screen. We do have some classes that are bigger than that. We also have classes that are smaller than that. So for example, right now, one of the classes that I'm teaching has 6 students. We have faculty members who have received national teaching awards, and also we have faculty members who attend teaching conferences so that we can be aware of what the best teaching practices are right now, and we can implement those in our classrooms. Now, a couple things that are additionally nice is, Dr. Coe was talking about how he originally wanted to be a structural engineer, and then he changed. I originally wanted to be a biomedical engineer, and then I changed. The point being, it's nice to have a little bit of flexibility in that. So Temple Engineering has implemented a common first year. And what that means is if you come into the engineering program, regardless what specialty you would be interested in pursuing, you'll take the exact same thing the first year. And that gives you that flexibility to explore and try to identify what really suits your interest. On the other end of the degree front, we have a program that's called a bachelor-master degree, or 4+1. And this is recognizing that a lot of engineers really are interested in achieving a master's degree. And so this is an accelerated approach that allows you to do that. And so you're able to do both a bachelor's and a master's degree in 5 years. And that's pretty cool. It's much faster than doing them separately. Finally, and you'll hear more about this later, but we have lots of students that are involved in research experiences. And so that's another way of understanding more what you're interested in and what are aspects of the field. All right, next slide, please, Colleen.
So in terms of our department has a number of degree programs within that you can come in and specialize in. What I'll talk about right now is the Bachelor of Science in Civil Engineering. As I mentioned before, civil engineering essentially has to do with all manners of planning and designing our infrastructure systems. And that can mean roadways, highways, bridges, dams, airports, all sorts of buildings that we use for any number of purposes. And so when you come into our curriculum, our goal with our curriculum is to expose you to these concepts, to how you go about planning and designing these things effectively, efficiently, in such a way that they will be resilient, durable, and last for the design life that is asked of them. Part of what we also do is look at, the economic feasibility of these projects and try to gauge, what sort of options can we pick along the way that will help us design things more cost effectively. And so as a student in the BSCE curriculum, you will be exposed to a broad array of the different civil engineering subdisciplines we talked about. Some of these courses are going to be everybody's got to do. For example, surveying, civil engineering materials. These are some of the courses at the lower division. So like within your first couple of years, because they're very common no matter what you are, whether you're doing structural engineering or geotechnical engineering, you have to understand, the strength of materials and what sort of testing we can do to evaluate that. What changes is just what material you're talking about. Is it concrete? Is it soils? Is it asphalt pavements, right? So some of these courses are going to be common to everybody. We like to make sure that everybody has at least one course in each of the different subdisciplines within civil engineering. And so, for example, soil mechanics, which is an introductory course in geotechnical engineering, everybody was required to take that course. Intro to environmental engineering, everybody's required to take that course, right? But what we also have is the ability to specialize a little bit, because we have technical electives that you take towards your third or fourth year that are much more specialized in a particular subdiscipline. So presumably by that time, you've started to gauge what your interests are within the civil or environmental engineering profession, and you might be gravitating towards one end of that or another. And if that's the case, then you have the ability to take some more advanced courses where we really get into the specifics of a particular subdiscipline. So for example, bridge engineering, we may focus on all the aspects involved with constructing a bridge, whether that's the bridge deck, the girders, any sort of number of aspects of a bridge. And so our curriculum is geared to allow you to have that flexibility to focus a little bit towards the end, with also exposing you to as much civil engineering as possible, so that when you go out and get a job, you also can get a job in any number of the different subdisciplines. You could go out and be a transportation engineer. You could go out and be a structural engineer just as well with our Bachelor's of Science in Civil Engineering. Now, Colleen, could you please?
Okay, so we have a similar setup in environmental engineering, which is to say that there are some required classes, and that is to establish the depth and the fundamentals, the critical aspects around environmental engineering. And then there's also some technical electives that you could choose to take. I'm going to highlight a couple in each category. So some of the fundamentals that we're looking for people to develop are understanding the types of processes that can be used for environmental engineering systems. And so those include classics like microbial principles, chemical principles, and then also looking at some of the kind of bread and butter aspects of environmental engineering. And so those include wastewater design and drinking water design. Additionally, as the world is changing, we're also trying to develop some of those new fundamentals into our curriculum. And so that's looking at some of the concepts around sustainability. So we do have a principles of sustainability in here. A couple other kind of core topics that are included in the environmental engineering curriculum as required aspects: hydrology. So again, that water resources question, we want people to understand how water will flow through a system. Also air pollution control. So as I was mentioning previously, it's not only thinking about the water, it's also thinking about the atmosphere and air atmospheric components, or thinking about the soil. To highlight a couple of the technical electives that we have, again, thinking about that sustainability aspect, we do have a life cycle assessment class, so that would be one opportunity. Here in Philadelphia, you may be aware that stormwater is a big consideration, and that's also true for a lot of other cities. So we do have a couple classes that are geared towards stormwater, And we also have a stormwater certificate that people can pursue as a mark of distinction that they have learned more about that particular topic. Another class that I'll highlight is Fate of Contaminants in Subsurface Environments. And that really means thinking about pollution of the groundwater. And so this gives you an idea of some of the range of technical electives that you can pursue, and you get to pick those. So as you move through the required courses, you can see what strikes your interest, what is maybe a direction that you want to go in the future, and you can select a technical elective associated with that. Now, as you can see over on the slide, there's some ideas about places that you're, directions that you might take. So drinking water and wastewater treatment, as I mentioned previously, those are really the cornerstones of environmental engineering. And so we have coursework to support that. Sustainability, that's one of our newer topics. And so the principles of sustainability and that life cycle assessment, those are both tools and components that could feed into that. Solid waste management, when you think about what happens when with your trash when you put it out on the curb, understanding those aspects. Also, air pollution and water reuse. These are topics that we tackle in either one specific class or spread out over a couple different classes. So, next slide, please.
Oh, there we go. So the third program that we have is construction engineering technology. And so this has to do with essentially anything that needs to be constructed, whether it's, what we talked about before, bridges, roads, etc. There's got to be somebody who is essentially managing how that project is completed, because it's one thing to design it and put it on a piece of paper. It's another thing to actually make sure it is constructed. And so our construction engineering technology degree program is geared towards essentially focusing on all aspects related to a project, whether that's contractual issues, things like how contracts are written in a way or things are specified for the projects, to scheduling, why is it that, we have to dig the hole first before we pour the concrete, right? And how much is each one of those things going to take? And how does that impact the overall timeline of the project? These are all issues that have to be addressed by construction engineers. And so our degree program in construction engineering technology allows you to expose yourself not only to the technical aspects of the civil engineering project itself. So how do you work with soils, with concrete and so on, but it also deals very much with the issues of how you actually get something constructed at a particular site. And so this particular curriculum is essentially another cornerstone of civil engineering, because without construction engineering, we cannot construct all the things that we want to do to make society function the way it does. And so we here at Temple have a program. Now, not every place has that. So I think this is a very useful tool or perk that we have here at Temple relative to other programs across the nation. Colleen, could you think? With respect to civil and environmental engineering, as I mentioned at the very beginning of the presentation, synonymous with civil and environmental engineering, I like to think is just in the word infrastructure. And infrastructure is everything we need as a society to function. All things we need to get from point A to point B, all things we need in order to make sure people are safe and healthy. And one of the things that is absolutely, completely been important is the fact that our country is not exactly doing a great job with our infrastructure. You probably see newspaper clippings and reports about this stuff. ASCE estimates that it would take $4.6 trillion in investments to basically get our infrastructure to a grade of what would be considered a B, which is a state of good repair, where there are things that still need to be maintained, but generally speaking, everything's functioning properly, and there's no things that are hazardous or problematic, right? Depending on what you're specifically talking about, we do better at that than others. And so our airports, for example, will get a grade of D in 2017. Other parts of it are doing pretty well. For example, we'll have our rails getting a B. And so the idea of a civil and environmental engineering program is really to fundamentally improve how our nation's doing with respect to our infrastructure. Because if we invest the time, the energy, and the money, and have good engineers out there to do this, we can fix these issues and make it so that our country is thriving even more and capable of meeting the challenges of the next centuries of societal growth.
Okay, so as Dr. Coe was just explaining, the nation really has a need for civil and environmental engineers to address some of these deficiencies in our infrastructure. And fortunately, society also agrees with this. So what you can see here are projections for employment opportunities, essentially looking for the 10-year time span from 2014 to 2024. So we're around halfway through this. But as we look at this, we can see that environmental engineering and civil engineering are growing more rapidly than other occupations. So civil engineering field is expected to grow by 8%, excuse me, and environmental engineering is expected to grow by 12%. So in other words, what we see is that based on national numbers, we're expecting to have strong job opportunities for graduates. And when we look around at our graduates, and you'll see more of this in a moment, but our graduates are very successful at finding both internships while they're going through their degree and also have good job opportunities after they graduate. Some go on to graduate school to pursue a more advanced degree, and some go straight out into the field and get a job and have a lot of success on that front. So go ahead and move to the next slide, please, Colleen.
Actually, if I could just bring in one comment about that too. One thing I would like to bring up is that civil and environmental engineering often, some of the engineering professions out there are sometimes can be farmed out. Civil and environmental engineering, you definitely need a local knowledge of the building codes and all the different regulations. So it's one of those jobs that you don't have to worry too much might end up in China or India, for example, because you really do need to have some sort of foot on the ground in the particular location. So, sometimes some of these software related or computer engineering and some of those face challenges with that because there's a growing populations across the world, and you may be in competition with those for some of the jobs that are available. But in civil and environmental engineering, there's very much a market for our graduates, essentially. So I just wanted to point that out really quickly.
All right, good point, thanks. So one of the things that we use in our curriculum in order to really both provide opportunities to develop skills and implement skills, but also to showcase skills, is the Senior Design Project. So the Senior Design Project is undertaken in the last 2 semesters of the undergraduate degree. So it's the second semester of the junior year, and then both semesters during the senior year. And it's undertaken as a group project. So the group project size ranges a little bit, but it's often around 4 people. And the idea is that you're taking the knowledge that you've gained from your previous classes, your ongoing classes, as well as some self-exploration related to those project topics, and you develop something that spans, a much greater extent and a much greater depth of expertise. Now, the cool thing about this is it also provides an opportunity where you get to showcase your work to your peers, to the faculty of the college, to your family, to some of the professionals in the community. And so you get to show everybody what you've been working on. So we usually would have an engineering day where that would occur. Obviously, COVID is disrupting that plan a little bit, but it gives you an idea of the approach to this senior design topic. Now, we'll see a little bit more of this in just a second, but the type of projects that we do in civil and environmental engineering cover a pretty broad range. So bridge design, you'll see in a moment that we have a team that participates in a national competition. And so that would be really well suited for structural engineers. We have green roofs. And so, for example, we had a team who was looking at doing a green roof retrofit. Let me take a step back. A green roof is adding vegetation to a roof so that it holds onto the stormwater a little bit more, so when it rains, and that provides some hydrologic benefits. It can also offer some benefits to the building. So this green roof project was a combination of environmental engineers looking at the stormwater aspects and civil engineers looking at the structural aspects. We've had teams that work on water collection and treatment systems. And so sometimes that's for a hypothetical building, sometimes it's for a building retrofit, or looking at, say, a water reuse opportunity. We've also had teams that look at more of the traffic aspects. So how to design roads or traffic systems that are better able to handle the amount of the volume of traffic that's going through that. Or sometimes, thinking a little bit outside of the box, it's taking tools like traffic flow patterns and applying them to atypical systems. So an example of that, we had a team this last year who was looking at the elevators in the engineering building, and they were trying to optimize traffic flow patterns there so that people could have a faster ride. So they took the principles of traffic flow, developed for roadways, and applied them to elevators to try to save people time. And I'm going to tell you from memory that I think that they devised an approach that would save a person on average 90 seconds. So that was pretty cool. And again, that's taking engineering tools and applying them to a new system. Colleen, if you want to advance, and we'll see a couple pictures about this. Okay, here's some ideas that you'll see for some of the national competitions that our students are involved in, and it's often done through senior design. The two pictures that you see on the left-hand side are what's called concrete canoe, and I have never participated in concrete canoe. Have you, Joe?
I was actually, in a former life when I was at my previous institution, I was the AAC student faculty advisor, and I was involved in concrete canoe because we had a team that participated. And
okay.
It's pretty fun because, I mean, most people think concrete canoe. Concrete can float on water, and believe it or not, it can. And that's part of the challenge, is trying to figure out what kind of mixed design will allow you to have the lightweight aspect of it while simultaneously being structurally rigid enough to support 4 people being on it during the actual competition. So they actually race these things as well. They not only build them and put them in the water, but they also race them. And inevitably there are some people who end up in the water, but that's kind of part of the fun and part of the challenge.
Yeah, so you can see how that's an example where you're taking the engineering skills and also some creativity and probably some trial and error and devising a new approach to this problem of creating something that floats and moves quickly. Another example that you can see down at the bottom, that's one of the bridge designs. And so that's the steel bridge competition. And usually with these type of national competitions, there's a core concept, a steel bridge, a concrete canoe. And then each year they might put in a little twist or a little requirement to it. And so that way the new team is required to re-engineer or rethink about the approach. Another example that's not shown here, but this coming year I'll be advising a team that's working on what's called the P3 competition. So that's people, prosperity, and the planet. And we're going to be working on devising a water filtration system, kind of like a Brita filter, that could be used to remove lead from drinking water. So that's another example of a national competition that's a little bit more oriented towards the environmental engineering side. All right, thanks, Colleen. If you'd move to the next one. One of the other things that happens in our senior design projects is we often will get interdisciplinary teams. So as much as a student comes up through the civil and environmental engineering program, the senior design projects can be a great time to experience interdisciplinary aspects. So working across the different majors that we have here at Temple. So an example of that would be one of my early teams, one of my early civil or senior design teams was, again, working on a water purification system, but it was for use in a place that didn't have electricity, things like that. And so We had some mechanical engineers who were working on the aspects of creating the structure. We had some civil engineers that were contributing to that too, as well as the sand filter. We had a bioengineer who was working on the best approach to inactivating bacteria. And we had an electrical engineer who was developing a low-cost turbidity sensor. So it covered all of the different disciplines, and it was a really fun project to work on there. Yeah, Dr. Ko, do you have any examples of other interdisciplinary teams?
Yeah, and from the civil engineering side, we've had teams before where, for example, I've advised a team where we created a shape table to mimic earthquake ground motions, where we could place a model of a building, for example, or a small bridge or something like that. And so it was in support of a competition where the competition itself was building, a model scale building to withstand certain earthquake forces. But then we also had a mechanical engineer involved in designing the table itself that would mimic the motions, as well as an electrical engineer that would design the control systems that would allow you to input some sort of ground motion. So yeah, there's definitely been some interesting applications of getting multiple engineers involved in solving a particular problem.
Very cool. One more example, my current senior design team, I gave them data from my house. So it was a year's worth of data on electricity use, temperature, and humidity from my house based on sensors that I had put throughout the house. And so they're working on trying to model my house and then think about approaches that could be used to improve the energy efficiency, considering not only the energy, but also the life cycle impacts and the economics of it. So that's just another example where I'm not focusing on water. We don't always focus on water. Here we're working on the efficiency of a classic Philadelphia row home. So again, more interdisciplinary aspects there. All right, if we want to go to the next slide.
So in terms of professional development, there are many opportunities for you to pick up experience that you can use in your future profession. We have a number of career fairs that are scheduled throughout the semester and throughout the year. Obviously, internship and co-op opportunities that exist with any number of these companies that are listed here, and this is just a not exhaustive list. Obviously, living in Philadelphia, we have a great environment in terms of a demand for engineers and a lot of engineering companies that will seek out our graduates. And so this is, like I said, by no means an exhaustive list. We also have an industry advisory board that is essentially made up of practitioners from the local area who have ties to Temple Civil Engineering in one way or another. And they help advise our curriculum to make sure that it's designed in a way that is servicing the needs of the local industry. And they often seek our graduates as well. So that's kind of another inside track by which we can allow, access to our students in professional development. And yeah, I think it's a great, if there's one thing that would be very beneficial to everybody is definitely to consider getting involved in internships during the summer or co-op experiences, because these things definitely differentiate you when you are finishing up with your academic career here at Temple University and seeking employment afterwards. In many cases, some of the places that people are doing co-ops and internships are places that have a job offer lined up, ready to go right when they're finishing up. So getting your foot in the door during these opportunities is very beneficial in the long run. Another area in which you are able to fully immerse yourself in the Temple experiences is our student professional organizations. There are, I think I've lost count. There's at least like 20 or something student professional organizations that are affiliated with engineering some way or another. In terms of civil and environmental engineering, the more common ones you'll probably come across will be ASH, which is the American Society of Highway Engineers, ASCE, obviously, the American Society of Civil Engineers, Engineers Without Borders, and the Society of Women Engineers. And these societies are beneficial in a number of ways. Number one, they provide a community for you, a way of establishing a sense of identity as belonging and being an engineer and belonging to a certain engineering profession. For those of you who are from underrepresented minority groups, for example, I'm the advisor for Society of Hispanic Professional Engineers. So there's a number of organizations that are geared towards the particular challenges faced by underrepresented minorities in engineering. There are other benefits in the sense of it allows you to oftentimes get involved in service projects where you are performing some sort of community service and you are interacting with the local community, interacting with the rest of the university at large as well. And so these organizations allow us to really get involved and, you know, make your mark while you're here at Temple University. Erica, do you want to add anything else about that?
Yeah, I guess if you want to go to the next slide, Colleen, because I know that one's about engineers without borders, and that's what I have the most experience with. So here's, you know, this is about engineers without borders, and as a student, I was heavily involved with engineers without borders. So again, as a student, I was able to put it on 3 times, I think, and that was not only fantastic as far as being exposed to a different culture and a different way that they approached problem solving and engineering and everything like that. It also gave me an opportunity to have some real world experience with engineering. Just as Joe was saying, to develop a community with my fellow students who were participating. And so that was a great experience for me. And I see that also in the students that participate in the various different clubs here at Temple. So again, Engineers Without Borders is the one that I'm most strongly connected with. So this is our Temple team working on a project down in Peru. They have gone down to Peru 3 times now. And each time it's just been a lot of fun, a lot of hard work, and a lot just learning about those different aspects. So this project, they've been working on a water distribution system. There was a spring that was up in the mountains, and so they developed an approach to successfully collect that water, store that water, and provide a pipe distribution system to a small community in that area. And so that's bringing water to the individual houses instead of having people walk to get water each day. And so it's just been a really, yeah, like I said, just a strong experience for the people to be involved with it. And each year we have more students that are interested in going on these trips than so far we've had an availability to support. But we look forward to continuing with this effort or a potential future project after COVID's over. So next slide, please.
With respect to our alums, you know, Temple University being, you know, what I consider the main university of Philadelphia, you know, it's servicing very much the needs of the local community. Our alums are heavily piped into the engineering companies that are around here in Philadelphia. In particular, Melissa and William, I know them personally because they actually took a number of my classes as well in the undergraduate as well as in the graduate program. I think both of them were the 4+1 accelerated master's bachelor's program, if I remember correctly. And, you know, I think what I can say specifically about the work that they're doing is they are ultimately having a big impact on Philadelphia. You know, the types of projects that they're involved in are very important projects that, you know, are creating new infrastructure for our city. And they are major contributors very quickly early on. I know that, you know, Bill would come talk to me about, you know, some of the projects he was working on, and I was very impressed with all the, you know, responsibilities they were giving him right away, given his, you know, relatively recent addition to the company. And I think it just goes to show about the strength of our program here, about the you know, instruction that you receive and the quality of advising that you also get to get you to these kinds of companies where they're putting responsibility on you right away. And our alums are meeting the challenge and thriving and are doing very well. So I think in the interest of time, we're probably running a little low here. I'll be a little quick more about the research opportunities. So I would encourage anybody who's in the undergraduate world. I know sometimes faculty can seem a little intimidating because we're just these guys in the office that teach you stuff, right? I hope but by us running this kind of a presentation, you'll see that we're regular people. You can come up to our office and come talk to us. I personally can, I'm sure speaking for Eric, I imagine as well, I love working with undergraduate students who are interested in getting a sense of what is out there in terms of research and in terms of my particular subdiscipline. So I would always, if you're interested at all potentially in research, go talk to the faculty, shoot them up an email, set up a time and chat, and we'll be happy to kind of go over with you what kind of work we do and what opportunities exist. Personally, I've recruited probably at this point, I've been at Temple for 8 years, I think about 20 something undergraduate students to work in my research lab. A lot of the work I do has to do with geophysical site characterization, non-destructive testing. The idea being, can we figure out what's going on inside something, whether that's underground or some piece of concrete or road or whatever? Can I figure out, are there problems with that by not having to actually slice it open or somehow get down? I mean, I'm a geotechnical engineer. All my stuff is underground. It's not easy to get to. So are there ways that we can figure out what's going on underground without having to actually dig it up, right? And so a lot of my work has been geared towards looking at various natural hazards and how we can quantify the extent of those natural hazards if they were to occur. Looking at particular defects in different materials, whether it's in foundations or in roadways. And then one of the biggest areas I've been involved in as well is unknown foundations. And this is probably going to make you feel freaked out, but there's literally thousands of bridges across the United States where we don't know what's underneath them. We don't know what foundation's holding them up. And part of what I've been doing with my research group is coming up with tools that allows us to figure that out without having to actually dig them up, because that can be dangerous and costly. And so, yeah, we do a lot of lab work. We do a lot of field work. That means we need a lot of hands on deck. And so I'm often, seeking out undergraduate students who may want to be interested and involved in that kind of research.
Okay, so my research, as I was saying earlier, I like to look at what happens with pollutants in the environment. And so this is just to give you a little bit of a snapshot of some of the types of things that we would do. So similar to Joe, we have field components. So you can see that down in the bottom left. This is looking at a stormwater area where we purposefully bring stormwater to manage it. In this case, we're trying to understand the flow patterns in it. So we've dyed it green. And that's just to let us see what's happening in there as, under a storm scenario, where the water would move and how it would distribute. We do also lab efforts. And so what you can see in the upper left, that little box with the little brown blob, take 5 seconds and think to yourself what that is. And if your answer was essentially broken down poop, you're probably right. So that is sludge from a wastewater facility. And we are trying to understand what the chemical contaminants in there is, what it contains. So again, we think a lot about the chemical contaminants, the pollutants, and what that means is it makes us applied analytical chemists. Now, I didn't like chemistry as an undergrad. I will tell anybody and everybody that. I hated it, actually. And somewhere along the way, I fell in love. And so these instruments that you're seeing there, those are the tools that we use to measure these compounds. So it becomes pretty fun on that front, because you can see the engineering that somebody else has done to create a cool tool to measure them. Now, the next step is trying to understand the data that comes out of that. On the upper right-hand side, you can see where we've collected samples, measured concentrations, and we're trying to understand whether these pollutants came from vehicles or, say, like combustion of coal. So trying to understand how these contaminants were released into the environment. On the bottom right, you can see that we're doing some modeling to try to understand how contaminants would move through this engineered system and how our design choices might impact that. So, just as Joe was saying, we've got some field work, we've got some lab work, we've got some modeling work, and all of that requires hands on deck. And also it provides a cool and fun opportunity for people to get involved and experience the research process. So I'd be happy to talk to any of you individually if you have other questions or curiosities on that front. So Colleen, I think we'll turn it back over to you at this point.
Okay, so thank you to Dr. Coe and Dr. McKenzie. That was really informative. I learned a lot about civil engineering myself. So at this point, while you're getting your questions ready, if you have questions for our faculty and hopefully soon to be our students, you're going to type that in the Q&A section. If you hover your mouse either at the bottom or the top of your screen, you'll see that option come up. So please type any questions that you may have. So while you're getting your questions ready, I'm going to introduce two of our current students in civil engineering to talk a little bit more about their experience from the student perspective at Temple. We have Javi and Jessica. And Javi, if I could turn it over to you first.
Okay. Let me just turn on. Oh, I can't turn on my camera. It's fine. Hi. So my name is Javaris. I'm a junior civil engineering major at Temple. I'm from Philadelphia, so I live 10 minutes away, which is the best thing ever. I am also part of some organizations here at Temple. I'm part of SHIP. I'm actually the vice president, and I'm also part of the Spanish club. It doesn't have to do anything with engineering, but it's still a good way to be out there, get to know new people, and yeah.
And Javi, could you talk a little bit about why you decided to major in civil engineering?
At my high school, we actually had an engineering department, and with that engineering department, our teacher was able to teach us different parts of engineering. And so what really interested me was civil engineering. So I really like the structure of things, how you start from ground to having a 20-story building or higher. We also had projects where we did make bridges out of popsicle sticks, and we also did our own handwritten drawings of our structures. So starting off with that made me want to continue with civil engineering in college. So that's why I decided to go straight to civil engineering. And there is a lot of opportunities with this major, so that's another thing. And talking about opportunities, this past summer I actually internship with a construction management company, and I was able to go to Nashville for the whole summer. So it was pretty interesting. We were able to work with the Nashville airport, and with the Nashville airport, we constructed 2 security checkpoints and a new concourse. So that was pretty cool.
Great, thank you. It was really interesting to hear. Jessica, can I turn it over to you next?
Yeah, hi, my name is Jessica. I'm a sophomore civil engineering major from Cherry Hill, New Jersey. I'm currently a part of SWE, and I'm rushing Theta Tau, the engineering fraternity. It's an academic fraternity, and I started rushing last semester, but I'm finishing it up this semester since we got sent home. I chose to do civil engineering because my dad actually works in construction, and so do his brothers and cousins, and I just grew up around people talking about plans to build houses and talking about home improvement projects, and it really fascinated me. So when I chose to become an engineer, I specifically wanted to be a civil engineer.
Great, thank you. So it looks like there hasn't been any questions that have come through yet, but one thing I wanted to touch on that we didn't mention is Dr. McKenzie talked a little bit about Engineers Without Borders. So you would have the opportunity to travel as part of the civil and environmental engineering major. But another thing that we do offer, if you've looked into Temple at all, is that Temple does have a campus in Rome, Italy. And there are study abroad opportunities available to the engineering major, civil engineering being one of them. So that's typically done during the second semester sophomore year. So you would still have the opportunity to study abroad. And one of the big advantages there is that it's still a Temple campus, you're paying Temple tuition, and you're taking all of the same classes that you would in Philadelphia. A lot of times with study abroad, some credits might not transfer back. You may have to go through other universities, but with our program, it's Temple in Rome. You have, again, all Temple classes, Temple tuition, and you still have the study abroad opportunity available. And as I'm sure you can all imagine, Rome would be a very unique and great place to be a civil engineering major, just studying the structures there. It is possible to do with some of our other majors, but it takes a little bit more planning. So you would just need to work with an academic advisor for that. But with civil engineering, it's specifically built into the curriculum that if you would like to go to Rome for a semester, that's absolutely possible. Okay, it still looks like we haven't gotten any questions yet, but we're happy to stay on to address everything else. I guess that means we answered all the questions that you guys have, which is, you know, Dr. Coe and Dr. McKenzie and our students were super helpful. So I hope you all found this helpful as well. As I'm sure you may have seen on our website, we're going to be having these types of sessions on a weekly basis pretty much throughout the next month or so. So we'll also be doing these for electrical engineering, mechanical engineering, industrial and systems engineering, our engineering technology major, and also our interdisciplinary engineering major as well. So if you're considering some of our other programs, definitely drop by. You can register for those on our website. And again, we'll also be posting the recording of these on our website as well. But if no one has any further questions, you're free to sign off. Again, we'll be sending out the recording of this webinar probably within the next few days or so, as well as posting it to our website. And you can also see our contact information on the screen here. So please don't hesitate to contact myself, Dr. Coe, or Dr. McKenzie if you have any additional questions. But thank you to everyone for joining tonight. I'm going to go ahead and stop the recording, but can stay on if there's any last minute questions.